Welcome to the DIY Honda Garage channel. The DTC P0793, identified as the Intermediate Shaft Speed Sensor A circuit, no signal, is a diagnostic trouble code that signifies a specific electrical issue within the transmission system of the Honda Accord, model years 2017 to 2023. This code is crucial to address because it affects the transmission's ability to receive accurate speed data, which is essential for optimal performance and safety. The intermediate shaft speed sensor plays a key role in monitoring the speed of the intermediate shaft within the continuously variable transmission, CVT, providing the transmission control module, TCM, with vital information to adjust engine power and shifting accordingly. Location-wise, this sensor is typically situated near the CVT drive pulley, connected through a 3-pin connector that facilitates electrical communication. It is important to note that this error code is strictly an electrical issue and not related to any mechanical fault in the transmission itself. Before proceeding with troubleshooting, it is advised to review general diagnostic information to ensure a systematic approach. The code P0793 indicates a fault with the intermediate shaft speed sensor A circuit, specifically highlighting a no-signal condition. The intermediate shaft speed sensor is a critical component that measures the rotation speed of the intermediate shaft in the CVT, which is responsible for power transfer between the engine and the wheels. Its location near the CVT drive pulley ensures that it effectively detects the shaft speed and sends this information to the transmission control module, TCM. The TCM relies on this speed data to adjust vehicle performance, engine power management, and shifting gear ratios. If the sensor begins to fail, or if there is an issue in the wiring connecting to the TCM, the signal may become intermittent or interfere with the proper functioning of the vehicle's transmission system. Therefore, identifying the exact cause of the DTC P0793 is of high priority for preventing further transmission-related complications. Various factors can lead to the triggering of DTC P0793. First and foremost, the most common cause is an electrical circuit fault, which can stem from a break in the wiring or a malfunction in the sensor itself. Poor connections at any point in the sensor's wiring can also disrupt the signal being sent to the TCM, leading to a no-signal condition. Additionally, open circuits or shorted wires between the intermediate shaft speed sensor and the TCM could severely affect the sensor's ability to relay accurate rotational speed measurements. To accurately diagnose this issue, careful inspection of wiring and connections in the circuit is fundamental. It is crucial to rule out any mechanical transmission issues, since this DTC is strictly related to the electrical componentry associated with the sensor. The symptoms associated with DTC P0793 can severely impact vehicle performance. Drivers may experience noticeable transmission performance issues, such as delays in shifting or slipping during acceleration. Erratic shifting behavior can also occur, making the driving experience jarring and unreliable. Additionally, the vehicle's dashboard may light up with warning indicators, alerting the driver to transmission problems. In some cases, the car may enter a fail-safe mode to prevent further damage, reducing power output and limiting acceleration. These symptoms not only affect driving comfort, but may also pose safety concerns if the vehicle behaves unpredictably on the road. Thus, recognizing these issues early on is essential for timely diagnosis and repair. To begin troubleshooting DTC P0793, first, turn the vehicle to the on mode, which powers on the vehicle's electronic systems without starting the engine. Next, utilize the HDS or Honda Diagnostics system to clear any existing diagnostic trouble codes. This step ensures that you are working with a clean slate and can accurately verify any current problems. After clearing the DTC, it's important to raise the vehicle securely on a lift, allowing freedom for the wheels to rotate. This step is critical, as it prepares the vehicle for the testing phases ahead, where simulation of driving conditions is necessary. Subsequently, enter VSA maintenance mode to ensure proper communication with the vehicle's stability assist systems. Following these preparations, run the vehicle at speeds exceeding 19 miles per hour, 30 kilometers per hour, for at least 30 seconds, which helps in generating a new signal for diagnosing the fault effectively. In the second troubleshooting step for DTC P0793, first, turn the vehicle to the off-lock mode. It is crucial to ensure that the vehicle is completely powered down before proceeding. Disconnect the CVT drive pulley speed sensor 3P connector, which allows you to isolate the sensor for testing. After disconnection, turn the vehicle back to the on mode. At this point, measure the voltage between specific test points to assess the health of the sensor's electrical circuit. Specifically, connect the multimeter to the female terminals of the connector, test point 1, terminal number 1 of the sensor, and body ground for test point 2. You are looking for an approximate voltage of 5 volts at this stage. This reading indicates that the electrical circuit is intact up to the connector point. If the voltage is present, you can move to the next troubleshooting steps. If not, further investigation into the wiring and connections is necessary. Step 3 involves conducting an open wire check on the VCC1 line of the system. Begin by measuring the voltage between test points 1 and 2 while the vehicle is still in the on mode, with the CVT drive pulley speed sensor 3P connector still disconnected. Test point 1 will be the female terminal number 3 of the sensor, while test point 2 remains body ground. It is essential to check for an expected voltage of approximately 5 volts at this junction. If the voltage is confirmed, this indicates that the VCC1 wire is functional, allowing you to proceed to explore further steps. If your measurement shows no voltage, this could signify an open circuit in the VCC1 wire that leads between the CVT drive pulley speed sensor and the TCM. In this case, repair efforts should be focused on identifying and fixing this break in continuity to restore proper sensor functionality. In the fourth troubleshooting step, you'll conduct a voltage check directly related to the CVT drive pulley speed sensor's performance. With the vehicle still in the on mode and the CVT drive pulley speed sensor 3P connector disconnected, measure the voltage between 2 specific test points. Test point 1, which corresponds to female terminals number 2 of the sensor, and test point 2, which is terminal number 3 of the same connector. Expect to see about 5 volts at this juncture. If you do get a voltage reading within the expected range, it indicates that the sensor is functioning properly, which means it should be replaced if it is malfunctioning. If no voltage is present, it suggests that the sensor may be working correctly, but there may be an issue with the SG1 wire connecting the sensor to the TCM. In either case, it is crucial to follow up with the appropriate correction based on your findings. Step 5 requires a focused check for shorted wires in the NDR PWM line, which can lead to faulty sensor readings. Begin by powering off the vehicle completely, turning it to the off-lock mode. Next, disconnect the TCM 50P connector to further isolate the TCM from the circuit. With the vehicle off and both connectors disconnected, you will check for continuity between 2 test points. Female terminal number 1, one of the CVT drive pulley speed sensor connector and body ground, designated as test point 1 and test point 2. The aim here is to determine if there is continuity. A yes response indicates a short to ground in the NDR PWM wire, necessitating immediate repair of any issues found. If continuity is not detected, you can move ahead because it indicates that the NDR PWM line is intact without faults, leading you to the next troubleshooting step. In the final troubleshooting step, you will conduct an open wire check specifically focusing on the NDR PWM line to ensure its integrity. With the vehicle still in the off-lock mode and both the CVT drive pulley speed sensor 3P connector and TCM 50P connector disconnected, measure continuity between test points 1 and 2. Test point 1 will be the same female terminal number 1 from the CVT connector, and test point 2 will be the TCM connector number 28. If continuity exists, it confirms that the NDR PWM wire is functioning properly. If everything checks out with a functional wire, consult any authorized service information related to the DTCs for possible solutions or known issues in the system. If issues persist despite the wire's integrity, it may be necessary to replace the TCM if substituting a known good unit resolves the DTC. This systematic approach ensures you're addressing the root cause rather than symptoms, ultimately leading to a successful repair. Upon completing the necessary repairs for DTC P0793, it is vital to engage in thorough final repair verification steps to ensure that the vehicle functions correctly. Start this step by rechecking all the connections that were disturbed during the troubleshooting and repair process. Properly secured connections are crucial in preventing recurring issues linked to poor electrical signals. Next, proceed with a road test of the vehicle under normal operating conditions to ensure that all systems are functioning smoothly. Pay particular attention to the transmission performance while driving, ensuring that there are no irregular shifts or warning lights. After the road test, use the HDS to confirm that no DTCs remain active in the system, especially P0793. This last verification step is essential to ensure that repairs have been effective and the vehicle is safe for regular use. For effective preventive maintenance, targeting reduction of issues like DTC P0793, there are several practical steps that can be implemented by vehicle owners. Regular inspection of wiring and connectors associated with the CVT system will ensure that any wear or damage is identified before it becomes a significant issue. Additionally, periodic testing of the sensors, including checking for voltage output and response in various driving conditions, helps to ensure they are functioning optimally. Keeping all electrical connections clean and free of corrosion will prevent issues related to signal interruptions caused by poor contact. These proactive maintenance steps can significantly extend the lifespan of the sensor and the entire transmission system, leading to more reliable vehicle operation over time. In summary, DTC P0793 serves as a critical indicator of an electrical issue within the intermediate shaft speed sensor A circuit for the Honda Accord model years 2017 to 2023. This code highlights the importance of the sensor, which plays a vital role in ensuring that the transmission control module receives accurate speed data for optimal transmission performance. Comprehensive troubleshooting, as outlined in the previous slides, is essential to identify the root cause of the no signal condition accurately. Repair steps may involve checking wiring integrity, verifying voltage readings, and ultimately addressing any faults in the sensor or associated electrical components. Regular maintenance practices can also play a significant role in preventing the emergence of this issue, helping ensure the reliability and safety of the vehicle. Addressing DTC P0793 promptly will contribute to the overall performance and longevity of the Honda Accord's transmission system. Please like and subscribe to the channel. See you next time!